So, welcome everybody. Thank you for joining us today. So, the theme of today's webinar and presentation is net zero buildings, and particularly how we add that kind of layer of credibility and verification that is really essential as we move towards net zero. And I'm sure you're all aware that this the push for net zero and ESG ratings has really been the most of the moment and the most heavily coveted and covered aspect of the built environment for probably about 18 months to 12 months, and the last 6 have really stepped up. So our aim today is really to give you as much of an overview as to what this means, how we can work towards it, and also be very happy to discuss at the end in the Q&A session any of the kind of wider impacts and relationships within, say, the wider economy and the energy infrastructure, and what net zero means on maybe just beyond the design and construction of buildings. So please feel very free to throw as many broad and wide questions as you may have towards the end of the session. So if you want to submit any questions via the Teams link, then please do in the chat function. So the presentation will be about probably roughly 35-40 minutes, and then we'll have about 20 minutes for Q&A. Okay, so to get started, I'd just like to give you a bit of an overview as to who 8 Associates are and some of the things that we do and some of the background and the position that we're coming from. So we very much started off in 2008 in the built environment, and a lot of the, I suppose, what we would now consider a bit of the kind of the bread and butter type work of sustainability, which is, you know, BREEAM was Code for Sustainable Homes, and now it's HQM, energy modelling, daylight, thermal comfort, air quality, ecology surveys, all those kind of good environmental reviews, indicators, and kind of assessments we undertake to verify the sustainability of the built environment. And as things have kind of matured and sustainability has more or less gone mainstream in many ways, that's kind of blown up to be beyond more something that's kind of just sits down at the building level, and it's become something much more on kind of for investors and portfolio clients and landlords, and then now it's moving up into the bigger, wider area of finance, and that's why we kind of having this prevalence and this overlay of ESG, which stands for environmental and social governance. In case anyone is not familiar with the acronym, that's really the kind of metric which is driving a lot of investment decisions and a lot of kind of the KPIs by which investors and real estate funds are looking at property, and that's what's driving a lot of this thing now, and particularly when we're looking more at health and well-being and the social aspects and benefits of urban development, infrastructure, and building construction. We're really trying to satisfy the ESG requirements. So that's moving into kind of the more finance area, and kind of increasingly we have the kind of corporate sustainability. So that can be organisations from a whole range of different sectors who need to get a grip with their carbon emissions and need carbon emission reduction plans, and that's feeding into this endpoint which we're looking at, which is this net zero piece. And as you're probably aware, the UK government has a net zero legal obligation now as of 2050. So the plan is to completely decarbonise the economy by 2050, and that's going to be quite a challenge. And there's some interesting aspects about that strategy, and I'm happy to discuss that at the end as well. And one of the key things to this, if we are going to set such bold, strong commitments, and we're going to kind of aim for this endpoint with ESG and all these other metrics that we have for scoring performance in terms of sustainability, a key piece of that is the assurance and certification, because one thing is making a statement, having a policy, but the key thing is actually verifying that we've actually achieved that in practice. And in many respects, this assurance and certification piece is perhaps somewhat what's lacking, and it's actually one of the key things that when we're looking at the higher kind of order operators in the industry, I suppose the investors and the real estate funds, that's what they're actually seeking now, and we'll come on to that later on in the presentation. So I suppose a quick overview of me. So I'm Chris Hocknell here. I'm the director here at 8 Associates, and a lot of my work is involved in, well, a whole manner of sustainability kind of works, but a lot of it's to do with energy, carbon emissions, and broader sustainability. And increasingly so, we're looking at climate change and climate resilience. So, this is also for buildings, but it extends beyond buildings. That we're going to have to accept that we're in quite in a dynamic and changing world, and what looks good or how things are now is not going to be the case perhaps in 10, 20 years. So we need to be looking at a lot of environmental challenges with that long-term mindset and working out what's good across a longer timeline and in multiple aspects, not just carbon as well. So that's also something which is probably worth discussing at the end if anyone would like to discuss that more. It's very important that we don't lose sight of the broader sustainability aim and just focus on carbon too intensely, because there are obviously multiple factors that feed into sustainability. So I think you're probably aware of many of these sustainability trends, but the key thing is that the direction is very much on the up. So I think there's a tendency sometimes to get a bit doom and gloom and negative about say net zero, sustainability and what have you. And the reality is, I think, is there is actually quite a lot of cause for optimism. So we have a whole load of commitments and varying kind of intimations of seriousness and commitment to achieving net zero and carbon reductions. That can be a building sector, company, right up to country level. Many of those are obviously commitments and indications, but we can look at it like this, where we have this expression of interest and this expression of purpose and intention by all these different organisations at different scales. The key thing is we just got to make them do it. So we have a huge amount of carbon emission commitments, and it's more a case of implementation, but it's much better to be in the implementation phase than dragging people's feet to the fire and kind of having to have the argument as to whether we should even be doing this. That used to be a lot of the conversations we were having in the early days of sustainability, but now the case for it is kind of somewhat of a given. It's now about how do we actually do this, and in many respects that's the more exciting piece for us, I think, as built environment professionals. So this is the real value of net zero. So I think it's often, I mean, there's no getting away from it. Net zero is going to be a mammoth task. It's going to need a lot of financing. It's going to need a lot of policy, regulation, and reconstruction of our processes, procedures, and the way we do things. That's really inevitable. We can't get away from that. But the reality is that we should be seeing this as a lot of an opportunity. There are many sustainability and wider social factors which actually complement things like net zero. For example, energy security, and obviously that's quite relevant with the happenings of Russia and Ukraine at this point in time. We can see the importance of energy security for certain countries. Fuel poverty is another one. Obviously, adding more renewables into the grid increases electricity prices. However, longer term, with retrofits and energy efficiency, that's going to be helping people in fuel poverty. So there's a whole load of accompanying pollution and environmental goals which actually then complement net zero. So it's very important we don't just look at net zero as a great big burden and an obstacle to overcome. We want to be looking at how we can actually overlap and kind of make the best of these aspirations, because there are many areas which it does, and it can be hugely beneficial for us in the long term from hitting these wider environmental goals. So we have a bit of movement in the, I suppose, in the regulatory sphere. We have mandatory climate disclosures, and as of 2023, the large organisations need to start reporting how they're going to reduce their carbon emissions. So that's a carbon emission reduction plan, essentially. And the key thing to mention here, that obviously these are enormous organisations like Unilever, etc., but a lot of their investment organisations, and one of what's a sound component of an investment portfolio, well, it's real estate, it's bricks and mortar, it's buildings. So this is going to trickle down, and already is. Many of these large firms, companies with assets, buildings, and maybe are investing in the real estate sector and properties, they all need to have carbon reduction plans and carbon disclosures in respect to their entire organization, their entire supply chain. So this is also a factor of what's driving it in our world, in the built environment. So when we're talking about net zero, it's very important to get the definitions correct. This is really in relation to buildings. So these are the two definitions. We kind of really split the building's carbon footprint into two halves. and one in construction and the actual assembly and production of the building itself, and then when it goes into operation, that's the other side of the coin. I'll just let you read those definitions. So the key thing is net zero is really about the as it applies in the, as you would infer from the name, the net piece. The reality is that at this point in time, we can't build a zero carbon building. We can't operate a zero carbon building. So we do as much as we can. We reduce it as much as we possibly can, and then we would have to purchase something like a carbon offset, where we basically commission a planting scheme or some kind of artificial environmental restoration project, which then sequesters carbon, captures it, and in the form of usually tree biomass, and then we kind of we either credit or debit that depending on the amount, and we get down to that zero where we kind of expelled carbon into the production and use of the materials, but then we brought it back down in theory through the planting of trees. So it's very useful to think about the this kind of what we call system boundaries, and if you're kind of used to the discipline of sustainability, everything about sustainability is about the boundary, and that can be essentially, you can think of this as to where we draw our remit. Where do we draw the extent of our system? What are we looking at? In many respects, many of the failings of sustainability and many of the perverse incentives or poor decisions that we can make in and around environment and sustainability is because we haven't drawn an appropriate boundary for the application or context. So one example of this I mentioned before about getting beyond just looking at carbon. Carbon's important, but it's also one piece of the sustainability puzzle. So boundary issues often exist when we have a laser-like focus on carbon and we forget things like land use change, impact on biodiversity, water consumption, pollution. And in reality, we need to weigh all of these things up, and that's the purpose of having a well-defined and clear boundary, and know what to include and what not to include effectively. So if we're talking in the realm of net zero and buildings, this is your system boundary. So we can see here, this is the whole life carbon. That's what WLC stands for. And now, for those of you who are familiar with doing planning applications in the Greater London Authority, they relatively recently released their whole life carbon policy document and guidance, and this is really what they're getting at. They're trying to look at the building asset from its entire lifespan. So you see here, we break these down into product stages, and you can see how they're labelled, and the lettering and the numbering. But really, it's obviously from, well, purchasing all the products, the assembly, the construction, the usage, the end of life, the demolition, and all the processing. And then we have this end piece, which is what we call the circular economy, which has gained quite a lot of traction, and there's quite a lot of buzz around that. But it's really about how we kind of obviously repurpose, reuse, and reclaim, and that gets put back into the materials cycle. And really, that's what circular economy is. It's that end bit that happens at the end once we've finished with our building, essentially, and how can we put that back into our loop and close that loop, hence the circular analogy, and repurpose and reuse. I'm sure I know we have many architects on the call and on the session today, and I'm sure many of you will be familiar with this. So Architects Declare has been a really good initiative. It engaged a lot of architects, and there was this big flurry of architects in 2019-20 who really got on board with the idea of a more sustainable built environment, and it's been a great job. It's done a great job of spreading the message and initiative, and I think getting the attention and engagement of architects. And it's obviously gone beyond UK now. It's in Australia. It's in many other countries, which is absolutely fantastic. The downside is, if you read this, what this is actually asking for is pretty demanding, and it's actually a step change in how we should be operating, and particularly how architects should be operating. And at the risk of ruffling some architects' feathers, many architects signed up to this not really sincerely or knowing, really, in my opinion, what this actually meant. If you read the text, it really says you are going to make whole life carbon, embodied carbon, just an absolute standard basic scope of works of your day-to-day architectural application of your trade, and that is very far from being applied. And it's a shame. I think there's a lot of LinkedIn and social media buzz and excitement and celebrating about it, but in reality, it's where this actually happens is where a life cycle assessment and material specification is put, front and foremost of MBS specifications, is put, absolutely the heart of architectural design, and it's not being left just delegated to say, well, the client didn't really want it, or the client didn't really didn't express an interest in it, or didn't have budget. It's our role, and I appreciate the difficulties and challenges of we're client-led discipline, we're a client-led sector. That's how we do what we do, but it's our job to be pushing this back onto the agenda and making those decisions everywhere we can, which are complementing the sustainability and the carbon footprint of our buildings. And I do think there's a lot of work to do, but working with like-minded people and collaborating and sharing and working together to put these things on the agenda, to have the conversations, to put the business cases to the client, to the PMs, the client representatives, whoever it might be. That's how we move the dial, and that's how we get the engagement. And we want to move this from being some kind of niche pursuit that happens on the Bloomberg building or some kind of niche buildings of multi-billion pound corporations in central London to something which is a standard operating procedure, no matter where you are in the country and no matter what the building. So I suppose these are the key areas that relate to embodied carbon. It's pretty important that we look at whole life carbon, but we also need to have a lot of focus on the existing building stock, which is what we'll come on to shortly. This is really a key part of the challenge here. New build and material specification for new build is very important. However, a lot of attention needs to be focused on the existing buildings, because as you'll be aware, about 80% of the building stock that we have at the moment will still be in use and operating in 2050, when we're supposed to have achieved our net zero goal. So why is this important? This is why it's important. We work with a lot of fantastic architectural practices and companies who obviously want to work very hard to reduce their own footprint, kind of their world, their office, their employees. That is great, and it's a good starting point, but we just want to put this in context. So this is a 60-person architectural practice in London, and you can see here that kind of pink dot on the top. That is the environmental footprint, or rather the carbon footprint, of all energy consumed from operating that 60-person office, 17 tons per year. Okay, so this is next down. We have the total office footprints. That's scope 1, 2, and 3. That's buying your fruit bowls on the Monday morning. That's your paper. That's your pens. That's everything that it actually takes to run a successful practice. Next down, we have the staff footprints. This is just the staff's lives. This is, kind of your staff are part of your company and part of the existence, and what's their kind of external life impacts. Well, their general day-to-day is generating around 500 tons of carbon per year. And then what's this? This is the sphere of influence, and this is the key thing that I want to get across here. This is the embodied carbon of the projects that that 60-person practice will be working on every year. And the whole point here is that we need to get some context. Like, it's all very good kind of recycling and doing all these things in our offices, but the key point is that we need to understand and pay, if we're serious about making environmental progress and achieving carbon reductions, we need to look where we can have the most influence. And this is a key part of the kind of I suppose the approach and the mindset that we have at 8 Associates here. When we're working with organisations, we identify the opportunities for carbon reductions, but then we need to understand the sphere of influence. We can have as many good ideas as we want, but if we can't implement them, or if we can only implement them to a limited degree, then we need to kind of think about how we change our approach and change what the way of implementing them, because the reality is that we never have enough resources to do our sustainability. We never have enough resources to implement. So we really need to pick our battles, and we need to work out where we can have the biggest influence. So this is a very, I suppose, pessimistic or kind of maybe realistic rule of thumb that we've taken from our years of working on life cycle assessment of buildings. So we believe that we can usually achieve about a 13%. So this is taken from the few hundreds of projects we've worked on in life cycle assessment for the last kind of couple of years. On average, this is the typical reduction that we were able to achieve through optimization of concrete specification, optimization of design, layout, whatever it might be. This is what we can usually achieve. And then the key thing to imagine or to kind of recognize, I think, is what if we could do that on all of your projects through a careful engagement, careful specification, careful design. That the order, the kind of the impact on the environment is orders of magnitude more than it would be if you went to become a completely carbon neutral office and completely neutralized all of the impacts of your employees. It's not to say we shouldn't do those things. Those things are really important, from the environmental perspective, because obviously many small contributions make a big contribution, and also it's really important that we spread that kind of literacy and have that behavior change within our industry. But we've got to keep an eye on the ball, and that the key thing here is the influence that we can have on our projects through minor modifications or minor enhancements can have huge benefits when we look at the impact of buildings, because it's important to recognize that an absolute phenomenal amount of carbon and resources is dedicated to the built environment. If you look at the construction, the maintenance, the operation, and the general, just having an urban and kind of built environment consumes somewhere between 40 and 50% of the world's resources per annum. So this is a huge amount of where our footprint lies, and it's important to recognize that small changes in a big system can have very high value benefits. So we're going to look at two areas, which are the two areas of net zero, which is embodied obviously, and then the operational. We've got a few slides on each, and it's probably just worth just digging into them, and just want to kind of maybe highlight some of the trends and some of the things that I think that it's kind of really should know and recognize. So this very useful, I suppose, rating system or kind of data set comes from Leti, which you probably many are aware of this. It's a really great kind of, I suppose, consortium of like-minded companies that want to contribute and share data, and they've come up with this banding because a lot of the problem we have within calculating embodied carbon is many clients, many practices still don't really know what's good, what's bad, and the reality is that we have very poor data quality. The data is very far from what we need to in order to make informed and intelligent decisions. So we often end up using a lot of generic carbon factors for materials and products, which is the best we have right now, but we need to very quickly move away from that. But this is where you would kind of, once you bring together your carbon footprint for your building, and then you put that into the metric of kilograms of carbon equivalent. So it's equivalent because it captures all of the greenhouse gases, methane and other sulfur dioxide, whatever it might be, these other kind of gases and pollutants which have an impact on the greenhouse effect. We put it all into the kind of a coefficient, or rather a CO2 factor, and then we roll it all into one. That's why it's CO2 equivalent. And then we divide that by the meter squared footprint, which is the GIA. We actually use the GIA of the building to get this kind of metric to compare buildings on a like-for-like basis. And this is what is considered to be high performance or medium performance, depending on where you're sitting. You can see the REBA 2030 target is somewhere in that kind of yellow, that B band. I think this is a really useful way of communicating because, as you're aware, energy performance certificates that we have in buildings and fridges and electrical goods has been a really useful tool for increasing the literacy of the of energy performance and sustainability more broadly. And it's my firm opinion that we should really look at moving to something like this for embodied carbon. I don't think that we should, we really want to move to a situation where it's expected that when if you're a landlord or a real estate investor purchasing a building, commissioning a building, or you're moving into a building, you get given an EPC by law. You should also be given an embodied carbon certificate, which is, or some kind of calculation, so you know what it is that you're buying, how carbon intense is this office, whatever it might be. And I think embodied carbon is now as important as operational carbon, so we need to treat them with a similar level of kind of importance. So just let you kind of just familiarize yourself with that slide for a moment. So embodied carbon is really important, obviously, in new build, because that's all these materials are being assembled. And if you look at the rough kind of, I suppose, a pie chart of the split between embodied and operational carbon. For a low carbon or well designed, say it could be a BREEAM excellent and above, or passive house, if that's certainly passive house, but then kind of a whole range of different high performance building or low carbon buildings in operation, you'll probably find that probably the split between embodied carbon and the operational carbon when the building goes into use is about 50-50. It depends on the use class, but it can be more either way. So that just highlights the importance of embodied carbon. That's why we need to put this emphasis on the reuse and retrofit of existing structures, and we obviously talk about this a lot, and we have a few kind of headwinds against us, and so that obviously the VAT difference that we have between refurb and new build is not very helpful, and we obviously know why the government did that is to spur on more new build, particularly new build homes. But what actually happens is it creates a bit of a disincentive. So we have many developers that come to us and say, we specifically are aiming to demolish this building so we can get a VAT benefit, which is obviously running very much to counter to our aspirations here. But kind of there's some quick rules of thumb here as to kind of the general impact of, say, structures and particularly aspects of structures as to why it's so important, as to why we can reuse. If we can reuse the existing structure, you can see that the benefits are substantial in terms of embodied carbon. Generally speaking, there is an argument that if we knock something down and thermally upgrade it, we can get a better operational performance. That is kind of, I think that is technically true. However, I broadly speaking, with the exception of heritage assets and listed buildings, I'm probably yet to see a building that can't be repurposed and reused and still achieve a comparable or like for like, all things considered, a kind of performance which is roughly in the same ballpark as a kind of a Part LA compliant building. Obviously, what the real constraints are kind of, turning circles, spacing, layouts, column layouts, anything like that. The kind of real practical aspects of ergonomics where the building might fall down. But purely speaking, from an environmental, sustainability, and kind of energy and carbon emissions perspective, reuse and retrofit is 9.9 times out of 10 better. So this is an example of, just to get I suppose a feel for this, is quite a big building in central London that we were working on, and we were basically a lot of retained but a lot of new, and we're adding stories onto this building. You can just see here the actual benefits. So this was our baseline here if the building was new build, best practice 2020, best practice 2030, and what we actually achieved. And you can see here it's a phenomenal reduction from reusing, say, approximately 50% of the structure and the kind of different aspects. We were able to maintain a hell of a lot of the frame and the external walls, which is fantastic. The roof, what we lost, and then upper floors needed a lot of repurposing, so that we lost that. But by and large, you can see that having such a large amount of retained facade completely changes the performance, and this is why it's so important. So I will just let you read this for a moment. You can see these are some, I suppose, some pointers and rules of thumb for yourselves to kind of familiarize yourselves with as to the kind of general benefits of embodied carbon or low in carbon specifications. So the first two are really kind of concrete, or rather cement replacement. So you can see we have GGBS and PFA, and these are basically kind of byproducts from the industrial process, which can be added as alternatives to cement in concrete mixes, and quite substantial. As you can see I remember from the previous slide, the structural frame is a huge amount of the overall embodied carbon. So this is really your first point of call, look at concrete mixes, look at structural steel, because these are where the probably biggest tickets items are going to be achieved. You can see plasterboard, so British gypsum, for example, are very good. Obviously, they're kind of the industry standard really for plasterboards, but you can see they're working very hard to improve the sustainability of their products, and they have something in the form of an EPD. So an EPD is an environmental product declaration, and this is really the gold standard of kind of environmental declaration. So if you want to go and find what the environmental impacts are of a product, if it has an EPD, by and large, it should be pretty clear in there. The main problem we have is that there are probably around 400 EPDs at the moment within, well, UK-based EPDs. So each country has an EPD system, but there's probably what 10,000, 15,000 materials easily that we use, and only a few hundred of them have EPDs. So the problem is data proliferation. We do not have good data, and that's why we use a lot of generic data, and that adds the huge amount of uncertainty in our life cycle assessment studies, and that's something we'll come on to later on. So obviously some kind of good rules of thumb here, which you as designers, you will all be aware of. Something to mention on timber, we get to count timber as being negative because, or negative in carbon terms, because it's obviously sequestered carbon from the atmosphere and has locked it into wood, and then we bring it into the building. Great, that's kind of a negative. However, how things are changing at the moment is that, you know, you've got all these I suppose kind of forestry commissions, and these other all these trees are being grown in other parts of the country or other countries, and there's a real question mark as to, as we place more emphasis on carbon sequestration, you know, does the seller of that timber and the grower of that timber, do they want to give that kind of carbon credit away? Do they want to kind of keep it themselves? Essentially, I think there's a lot of there's going to be, in the next year or two, there's going to be a lot of kind of fighting over this to work out who gets to keep that carbon credit, because obviously the grower, the supplier, the installer, the building, they can't all keep the carbon credit to their kind of for their benefit, and there's going to be a bit of a battle undertaken as to who gets to count it. So in theory, when it's sourced properly and you get to credit it, it's a great addition, but that might not be the case, and I think there's a lot of battles going on at the moment as to who's going to actually credit it. So one of the kind of constraints here, I think, that we often see when we're looking at timber and other kind of more sustainable products like CLT is actually insurance and fire issues. We had a project where we proposed CLT floors, which was a huge part of the embodied carbon reduction piece. And what actually happened was we went forward the specification, we got to kind of REBA 3+, and then the regulatory and CDM and fire people looked at it and said, there's no way we're going to get insurance on this because of fire issues. So what do? We defaulted right back to concrete. So these are some kind of, I think, some of these big kind of industry issues that we're going to have to tackle. And it's often, as you will all know, as designers and built environment professionals yourselves, it's not just about getting a good specification. We are often scuppered by other challenges such as regulatory and the kind of general conservative nature of specification and doing things differently in the industry. And this is really something we need to flip, because we're not going to move forward with these kind of challenges. So there's a lot of work for people in other disciplines to do, and I suppose the big insurance and you know, other organizations and bodies to kind of get on board with what we're trying to do here. And I think that's happening, but it's obviously we still got a bit of a way to go. One of the key things which I think is very, very important to consider, and this is a really important part of embodied carbon and building design, is life expectancy. And the key thing here, I think, is not to just say materials that last a long time are better, because it's more nuanced and more sophisticated than that. It's all about matching the anticipated life expectancy with the durability and life expectancy of the given product. So there's this. You'll probably be familiar with this. This was, I suppose, a theory or a principle that was developed by an architect in the 90s, and I believe was informed by something that came earlier. However, the key point here is to not to look at the building as a single entity, because it really isn't. It's actually it's an amalgam of different layers doing different things, and the key thing is to work out how we theoretically and technically approach this, because we want to be specifying products that are applicable to the relevant kind of lifespan. And for example, when we're working in We have a lot of challenges with retail clients, commercial clients, but particularly retail, who will do, retail fit outs on a mall or a kind of a little outlet store somewhere, and particularly luxury brands which have specify incredibly high carbon, very beautiful materials, brass, marble, etc., whatever it might be, and then it's going to get taken out in 5, 6, 7 years time because the concept changes, the aesthetic needs to change, and all these materials which have a technical lifespan of 67, 100, 200 years potentially are kind of getting ruined and they're being not being used to their fullest effect. So I think it's very important we look at this. They take this mindset and this design philosophy about layers and work out how we specify appropriately for the I suppose the component in question. If you wanted to think about a metric as to how successful we could consider a building to be in terms of its adaptability, generally buildings succeed or fail on their ability to incorporate new technologies and new, I suppose, changes. So how well a building can incorporate changing kind of interior layouts, interior fit outs, and particularly building services, the interfacing between building services and the structure and maybe the more kind of architectural and structural pieces is usually a big challenge for us. And buildings that can incorporate turnover of services and kind of space plan, that's where the success is achieved, and that's really can be considered the metric of performance there. And generally speaking, with things like the structure, we want to design that structure to last. We do anyway, by virtue of the material specification. But really, I suppose we want to be thinking, ideally, perhaps this building could be here for exceed our lifetimes and perhaps even subsequent generations. That's probably the best way to approach structure. Design it really to build the standard test of time. And you can think about this kind of fantastic legacy we have with, say, all the Georgian buildings, etc., of that era that we have within our cities, these beautiful buildings that they're going nowhere, and we have this gift and we have this kind of embodied carbon and these materials that are locked in for the long term, and that's an example of beautiful, well-built buildings that will stand the test of time, and we have that kind of excellent benefit of that embodied carbon over the long term. So these are just guides, and I know we have a lot of architects, but when you're and perhaps a couple of structural people on the call, but when you're dealing with your structural colleagues, these are probably a few things or some things to bear in mind. General rules of thumb in terms of kind of trade-offs. One of the key things, I think trade-offs is one of the key important factors to consider really for when we're looking at design, because there's never that ideal option. There's always ramifications and implications of doing one course of action or another, and we do need to bear that in mind. But generally, this is a typical split of what we found from our data based on the relative or respective rather environmental impacts of each of the structural components. And the key part here is the sensitivity analysis. So this is obviously kind of an analytical tool or method where we actually look at the impacts of changing specification or adapting or augmenting a particular specification. And naturally, when something's very sensitive to change, i.e. if something changes by 5%, there's an increased environmental impact. So small changes create big impacts. We want to steer away from those because we know that things change. We know there are variations. We know we get challenges occurring, and things aren't static all the time. And if we have very sensitive design specifications, we don't want to come unstuck later on. So we should probably have a preference for less sensitive decisions and specifications. Something to bear in mind on the structural side here is that we do tend to over-engineer. Now, this is not necessarily a bad thing. We have a lot of practices, and we have a few engineering practices which are greatly respected and fantastic kind of professionals. However, I've heard some of them stating that we should the so-called climate emergency is now, so we shouldn't be over-engineering. We need to go right up to the minimum we can get away with our kind of structural thresholds and leave it there. I actually completely disagree with this philosophy. I think that the reality is we don't want to be ridiculously over-specifying, but the reality is that I think one of the key things we've learned in the last couple of years is the need for buildings to be adaptable and to repurpose. We don't know what the future is going to look like. We have no idea. And you know, in 10, 20 years time, who knows what we'll be using these buildings for and how we will be applying them. You know, when we're having these functionality workshops with clients in 2019, we'd be saying, can this building change use class? And there was always a slight kind of insinuation that it was a ridiculous proposition to be looking at this in from from an adaptability and functionality perspective, because the planning says it's an office use class and it will never change. Well, COVID hit, and then what happened? We have a number of developers who were in the office space, and we have a number of landlords who own offices are now looking at changing that to, you know, some kind of residential use class, and what else, these kind of more flexible kind of workspace, or whatever it might be. Looking at changing use classes for these buildings, and these are many of the same clients who said it was kind of ridiculous to be looking at functional adaptability because it is what it is. And I think we just need to bear in mind and have a bit of kind of humility about how little we know in terms of how things are going to be in 10, 20 years time. So I think a bit of over-speccing and over-engineering is actually very useful. Example might be many of the buildings that we work on that are kind of adding floors to, or expanding. Maybe were built in, say, 60s, 70s, 80s. We have this legacy actually where it's actually very easy to add floors onto some buildings because we have this legacy of over design and over engineering, and we wouldn't be able to do that if you know, this structural design had been taken to the absolute bare minimum of compliance. We didn't have any headroom in the design. So that's a gift that we're making use of now that was given to us from the 70s and 80s carbon kind of input. And I think we need to just bear in mind that we want to allow adaptability and flexibility for our future kind of building professionals to do a similar thing. So again, MEP engineers, kind of quick rules of thumb here, just to acknowledge and kind of I suppose to be in mind of. Depends on the use class. It's very sensitive to use class, this one, as you would imagine. It can be as low as 15, can be up to 40% of the embodied carbon of the entire building. Electrical is probably higher than mechanical, all things considered. It's probably up to half of the total MEP installation is the embodied carbon comes from electrical. And refrigerant leakage is also another thing which is probably neglected, but is quite impactful. And yeah, one of the key things, I mentioned the energy performance declarations before. We don't really have this for the MEP, so we can have certificates and declarations for plasterboard and concrete blocks, kind of inert and simple elements. But when it comes to things like lighting and air handling units, because they're very complex products, we don't have environmental data, which really makes things very difficult for us, because it's very difficult to see if an air handling unit from one company is better than another. You know, this one might be slightly more efficient, but then it's slightly heavier. We're using very, very rough rules of thumb on this, and the sooner we get better data, the sooner we can make better decisions. So just moving on to operational carbon. I'm aware of time, so I'll move on to operational and then just close with the importance of certification. This is roughly our interpretation based on Committee on Climate Change and other data as to where the split of kind of carbon emissions is going, or the reduction in carbon emissions is going to be made in order to hit net zero in operation. So you can see new build probably comprises 15%, something like that, of where our efforts are going to be put. And a big chunk naturally is energy efficiency. We obviously have this mantra of fabric first, which is absolutely correct, but we don't want it to become fabric only, because again, we've got limited funds, we've got limited capex to deploy when we're looking at sustainability strategies and construction and refurbs. It's important to recognise that a lot of the existing building energy and carbon reductions are going to have to come from the energy system as well. So it's not just about kind of designing down to zero energy demand buildings. Again, we need to look at where we can spend our money. The key thing is, obviously, if we have a low performing energy, low performing thermal kind of envelope and fabric, that creates a whole lot of problems for us, which are kind of manifest themselves in the MEP specification. So it's really important we get that fabric right first, but it's worth bearing in mind for in our existing buildings, a lot of it is going to be heat pump led, potentially low carbon networks. We might be looking at kind of moving to a hydrogen based fuel source as opposed to gas in 20 years time. To be honest, we don't know. This all is down to government, huge infrastructure plans and what have you. But the key thing is, as you would imagine, get the energy down, energy efficiency down, and be enable for adaptability, enable to be, for electrification. Can heat pumps be incorporated on our existing buildings? That's going to be a key metric for adaptability and the ability for our existing buildings to become zero or low carbon in operation. This is kind of your timeline for operational carbon. You might consider that something of the similar kind of trajectory occurs for the embodied, but you can see here we have this progressive tightening of EPC bans getting tightened. As you're aware, you can't rent F and G, and then we've got the kind of restrictions on Cs coming later in the future, and phasing out of gas boilers. So we have this kind of trajectory of tightening of the regs over time, and you can probably expect a similar thing to be happening over the embodied carbon. And this is something that just mentioned, the fabric first trade-off. It's quite important that we just bear this in mind. So this is kind of retrofits of maybe hard to heat properties and hard to treat properties rather. So you can see kind of the cost trade-off there. Roughly a heat pump installation and external wall insulation on a single dwelling is about the same cost, but in reality what would save more carbon would actually be the heat pump. So this is just something to bear in mind. We have, as I said, fabric first is absolutely right, but it can't be fabric only. And if we find trade-offs between kind of potential, we know that we get a lot of bang for our buck in, if we treat a solid wall and we insulate it, we get a huge reduction, which is great. But those kind of more marginal thermal upgrades, we want to be looking at that and thinking, is that the best place to spend our money? What if we were to kind of to flip from a gas boiler to a heat pump on this scheme and what have you? So we need to be thinking of where we have the best kind of influence and the best kind of carbon impact based on the kind of the context of the dwelling or the building in question. And this is obviously quite a lot of text here, but this is just really showing, I suppose, the kind of the cost curve. And then the key thing to point out, if you look on the left here, you can see this graph, that cost curve is increasing. And that's the key thing to mention. As we know, the kind of cost of reductions doesn't go up linearly. It's kind of an exponential curve, and at some point we reach a limit. And if we're looking at this from the big picture level, and we had, say the government's going to come up with some kind of budget for treating properties, and it might be 250 billion. That's maybe a bit more depending on who's recommending it. That's the kind of scale of the retrofit ambition and the scale of the money that's planning to be spent on one way or another. We probably want to think we want to spread that in the right areas. We don't want to take a small slither of buildings to the highest possible performance that they possibly can and neglect others. That money needs to be spread evenly and fairly and appropriately across the entire stock. And obviously, if we have non-linear cost curves, we need to think about where we want to sit on that curve. This is more, I'm not saying there's one right answer here or not. This is probably more food for thought. So finally, we talked about embodied and operational carbon. One of the key issues we have with net zero, life cycle assessment, and footprinting of buildings is really is the data correct? Are the calculations correct? And we have lots of people saying different things. We get wildly different results. So one of the key things that we need to recognise is the importance of verification. So we looked on the marketplace and we couldn't find anywhere or anything that was delivering anything like this. UK GBC were talking about setting up a net zero building certification. They went out to consultation, or they kind of posed it in a question. They haven't really moved that forward as far as we can tell. So we kind of took it upon ourselves to put a bit of a line in the sand and say, this is what we consider to be the appropriate level of verification certification. So as of next month, we'll be having a hard launch of our verification standard. But the key thing is that we need the key thing that we need to consider here when we're looking at net zero certification for buildings is the measurement needs to be complete. It needs to take into account practically everything we can within reason. It needs to be verified, so it needs to be a third party needs to review it to check that the data is correct, the calculations are correct, and the key thing is it needs to be accessible. So we basically set up I suppose a sister non-profit called Natural Carbon Solutions, and the role of Natural Carbon Solutions is really to kind of have this standard, to have this protocol, which will verify calculations and measurements done by 8 associates, architects, whoever it might be, verify that they actually are complete and that they meet the aspirations of net zero, and then issue a certificate saying yes, this building is calculated to be net zero, and you can see it complies with all of these standards at the bottom. So the British Standards Institute, the Greenhouse Gas Protocol, the international ISO standards, and the key thing is with it being very low certification fee and everything like that, we want to make sure it's accessible and it can be used by as many organisations as possible to have that confidence. And this is what's going to feed into the wider ESG agenda, where investors and real estate funds, etc., can have that confidence that the statements around buildings have been verified and kind of accounted for one way or another as being accurate. So it doesn't necessarily just have to apply to buildings. One of the key things I mentioned was in environmental product declarations. So a lot of the building products we have don't have declarations. We don't know if tile A is more carbon intense than tile B. We've just got a slight bit of inference to go on. We need to really get over that. And the key part of what we're doing is we're trying to reach out to product suppliers, building materials manufacturers, wherever it might be, and say, can we actually produce a carbon footprint for your product and give you a certificate at the lowest possible cost? So we can just, our aim is to fill the marketplace. We need to proliferate data and transparency as much as possible. So when you as built environment professionals are looking at specifying or working on kind of buildings, design and what have you, you need to be able to pick the best product, the best window unit, the best glass, the best stone, whatever it might be. You need to know what data you're working with, and the moment we just do not have that, it's a complete vacuum of data, and we're going to try and work to fill that as best we can, so the likes of yourselves and other built environment professionals can make the right decisions. And this is really how it works. I suppose we kind of need to look at whole life carbon and life cycle assessment at the REBA stage 4, but the key thing is we need to produce an as-built whole life carbon assessment. This is really important, and we need to have, because it's not just about design, we know things change, and if we don't really have a footprint that's complete as built and practical completion, we don't really have a footprint that we can vouch for, because we know how things change. We know the materials that go in are different from what we had in at REBA stage 4. So we need that as built certification. That's absolutely essential. So we can see we have obviously the GLA and LETI and UKGBC and REBA's 2030. These are all benchmarks which are incredibly useful for us to know where we sit, but we don't have certification and verification yet. And that is the express purpose of the Natural Carbon Solutions kind of framework and protocol. And we have a similar model for operation. Obviously, we do an energy assessment at stage 2, and we do our SBEM modelling, but we need to kind of, when our building goes into operation, it needs to be based on real data, not hypothetical model data, and that's the key thing there. So it's basically based on meter readings, real energy consumption, and we need to prove that the amount of offsets being purchased actually means that we're netting off and getting down to that magical net zero target. And naturally, you want to start off the processes, we need to reduce first, we measure, then we reduce, then we look for net zero, and eventually we might even go climate positive, which is where we're putting back more than we're taking. That would be the dream scenario for decades ahead, but it's worth having that end point in mind. But the key thing is, first and foremost, is to measure and then look at reducing, because you can't manage what you don't measure. So we need to get that measurement right, and then we can move forward. So yeah, that more or less closes the presentation. I hope you found it useful as to a bit about embodied carbon and operational carbon and the importance of certification and verification. Would absolutely love to take any questions. I'm aware we're more or less at time, so I will take questions which have been put in the chat or emailed in prior, and I'll do that now. And maybe perhaps for anyone who who needs to scoot off, please do feel free to reach out to us with any targeted questions. We're more than happy to reach out to you on a one-to-one basis. So we have one question here from Lisa about, do we need to find plasterboard alternatives? And I think yes, we do. I think this is where we kind of tend to stray a little bit into the realm a bit of material science, and I think it's probably quite important for us to recognise that net zero in the embodied carbon side of things is just not it's not feasible without the most enormous kind of change in material science and R&D, because we can't keep offsetting forever. You know, a phenomenal amount of our materials come from the likes of China, for example, which has an incredibly carbon intense grid. They burn most of their fuel, most of electricity comes from coal. So one of the kind of problems we've had of our deindustrialization in the UK and the EU is that we're now importing more and more products than we ever were for buildings and materials, and they're hugely carbon intense. They're actually more carbon intense than if they would have been if they'd stayed within kind of Europe and the UK. So there's not much we can do that and we do about that, and we need an enormous innovation in kind of material science and materials products. We have some crazy materials that are still in R&D and kind of university level, and they need to be commercialized. Unfortunately, we're probably quite a way away from that. But plasterboard is one of those things where it does have some poor ingredients that obviously we can't put it in landfill. It's really not the most ideal material. I think really kind of, I believe there's a lot of kind of progress being made by plasterboard manufacturers. So they know that's a bit of one of the kind of the red list materials, I suppose, that we look at from an environmental perspective when we're looking at a kind of life cycle assessment and sustainability. One of the key things I think actually at this point in time, I mean, if you can find something that has a different or is a relevant and applicable alternative to plasterboard and is acceptable, then great, then do it. But in reality, we'll probably need to be looking at this point in time, because of its kind of prevalence, we probably need to be looking at take back schemes, first reducing it wherever possible, and looking at how we can add this kind of circularity. So for example, British Gypsum state that they will take all offcuts back, which is a positive thing, because then they're not going into waste. I think what we're probably going to see is some of these material suppliers are going to have to move to something more of a kind of a closed loop model, where they will guarantee if it's their product they will take it back, or they'll repurpose it on the whatever it might be. That is probably going to have to be their model that they're going to move to. So I would try and kind of look at how you speak to manufacturers, particularly British Gypsum are kind of one of the better ones, but there are others out there, and speak to them about what they're doing in terms of take back schemes and how they move into more of a circular model. And yeah, that's probably the best way to proceed at this point in time, because at the moment there isn't probably a like for like replacement for plasterboard that has the same qualities. Okay, I don't believe there are any more questions, so I will just thank you all very much for attending, and I hope you found that useful. If there are any more questions or any queries that come up after this or whatever that may be, please feel free to reach out to us, and we're more than happy to have a conversation about anything and anything sustainability related, and we'd love to talk and share and help wherever we can. So thank you very much for your time. Hope you have a good day, and we'll hopefully see you soon.